We are talking about large language models and how they are enabling network analysis. I am Elizabeth Press. I am owner of D3M Labs, and I am here today with Sven Zavitz, who's a computational biologist. Sven, thanks for joining us. Could you tell us a bit about how you got into computational biology and what actually computational biology is for our viewers?
Sure. Thanks a lot. Thanks a lot, Elizabeth. Thanks for having me on. I started out in lab-based experimental biology. I did my PhD there and my first postdoc, where we were generating a lot of biological data. So this was going back quite some time now, and I was seeing that the amount of data that was being produced was ever increasing. So just as an example, I was doing my experiments in 96 well plates, and people were using like 384 or 1596 well plates. So the amount of experiments that could be done in one shot was increasing. That also meant the amount of data coming out of these experiments was increasing, and I was one of the people in the lab who had to then analyze the data. And it very quickly became clear to me that this was the real bottleneck in understanding biological systems, is to get to grips with the actual amounts of data. So that brought me into computational biology. So just as a quick aside, so computational biology really tries to understand biological systems using computational methods, which is a slightly different thing from bioinformatics, which is more in trying to understand the biological data. So there's a huge overlap, but sort of one is slightly maybe the superset of the other. So that was how I got into computational biology. I retrained, I taught myself to program, and then I got a further postdoc where I was very lucky to work with some excellent computational biologists and systems biologists to try to hone my skills.
Thanks. And you and I had talked about network analysis. Could you talk about what network analysis is and why you think it will be a new paradigm going forward?
Yeah. Thanks again. So this is a wonderful question, because it really strikes at what really motivates me in this field, Elizabeth. So very early on, when I was doing my undergrad and I was, for example, doing genetics, the mantra was always, yes, we know, the whole is more than the sum of its parts, and we understand that, but we're still only going to analyze the parts, which is what genetics could do at the time. You knock out individual genes and then you see the effect. So you were very much concerned with just analyzing individual components, fully acknowledging that a biological system is more than just these individual components. But we were leaving that out because there was no methodology to really understand the whole. Now that sort of changed over the last basically over the last decade, where networks are trying to recapitulate the whole and then understand what emergent properties arise once you put everything together into a network. And that's why networks are so key, because every biological system is a huge amount, not just one, but many interacting networks. There's signaling networks, there's gene regulatory networks, there are metabolic networks. Everything interacts in a really, really finely tuned way, and understanding those interactions is really, really key. And for that, you cannot do that without network and network biology and network science.
And you and I had also talked about large language models. So could you tell us why large language models are such an enabler now to network analysis?
A really fundamental problem in data science, and especially in biological sciences, where there's a huge amount of data available, but it is very, very distributed. And we and other groups would come to that problem many, many times, and it's an industry-wide problem, where you would love to be able to access like a huge data set of someone else, like a public data set of proteins, or a data set of medications, or a data set of your metabolites, and they've all been curated to a high standard, but they're using, for example, different nomenclature, different annotations, and doing that by hand, integrating that, is really, really hard and really time-consuming and does not scale. And there's a huge amount of problems associated with that. So now we have the first chance of using large language models, basically, for example, for data harmonization. And people are trying that out right now. And I just read a paper yesterday by a group of the European Bioinformatics Institute, where they were using ChatGPT, literally ChatGPT and GPT-4 for data integration purposes, just to sort of harmonize different, or find new pathways, or integrate new proteins into new existing pathways. As it stands right now, in their estimation, it's not yet there yet. So this wasn't a lot more efficient than doing it by hand, but we are very, very early at the stage. And they even, of course, everybody acknowledges this is a trajectory that we're on, and future language models will be much, much better. So that's just one use case, the data harmonization. There's a huge amount of others, data quality improvement, or summarization, or even abstracting maybe from individual pathways and trying to understand, their function or their purpose, or other things that was previously completely impossible to even ask.
So if I take a very practical view of this, I'm a manager and I hear what you're saying about network analysis. Wow, awesome. And now we have large language models. Also great. What's standing in my way of actually implementing large language models and using them to enable network analysis in an actual company or governmental organization?
Right. So first of all, I think also, just briefly discuss this. I think the key point is here. Right now, we're still at a proof of concept stage, right? We're trying this out. People are putting up these prototypes, testing how much this works, and seeing to what degree this enhances their own workflow or not. I think the promise is definitely there. In this one instance, as I said, it was rough. It was just a bit faster than doing it manually, because there's still a huge amount of human interaction involved. For example, they hallucinate. As we all know, they hallucinate, citations. But there was, even in this case, they did find 5 new proteins within a day, which is huge, right? You're finding new components, you're finding new insights within a fairly short amount of time, with language models that have not been trained specifically for their domain, right? This is just whatever ChatGPT was trained on, everything but nothing specific, and they were still, having problems with that. And there's wonderful also examples of being able to maybe reconcile contradictory or highlight contradictory information that is really hard to find otherwise. You might read 1 or 2 papers, but maybe there's another paper that actually contradicts that. So being able to find these inconsistencies is wonderful and really, really valuable. So there's a large number of use cases where large language models can greatly enhance your workflow. But as we were saying, we're still at the proof of concept phase. You have to really assess where you are, but I think it's really worthwhile to dig into that and to see in what time you need, or at what time in your workflow, in your process, will you be able to implement these fully fledged. And I think it's not far away.
And also, what about the companies themselves and the infrastructure that's needed? Because you do need some sort of database harmonization.
Yes.
You do need to have the GPUs that will enable you to do all of this.
Yeah.
Could you tell us a bit the road that a lot of companies might have to go in before they could actually do what you're saying?
I know you definitely need, you need your own data to, for example, to train your language model on. I think that's probably the first step, is to make sure that you have a good starting data set. And I think there's a lot of companies putting effort into making that much easier. Sort of, there's now, I went to a talk from Google where they were showing off their capabilities, where you can now, in a point and click way, just train the chatbot, for example, on your own data lake, on your own data repository, whatever that may be. So this is already a huge step. So these large companies are putting in the infrastructure to allow you to train your models according to your use case. Then, as much as further infrastructure goes, I think this really also depends on probably where you are in terms of your own setup. There's probably going to be a need for a lot of compute time, and I think there might be vendors who are really specialized in that, and you can interact with them. And I think essentially it's really trying to assess where you are right now, but I think also taking some bold steps in assessing how much you can push this technology and be at the forefront of this development.
Great. And there is also the education and cultural aspect that needs to change as well. Not every analyst is able to do network analysis.
You can suddenly ask much more higher level questions. And I think this is also the key education that needs to happen, is that you don't have your data asset and you're doing the exact same, you're asking this exact same questions. You can ask much more high level questions to your data, which then potentially creates a huge amount of new value. It leads you to new targets or new modalities, or if you're in the pharma space or whatever space you're in, you can adjust accordingly. So I think there's a cultural change required, and education of your own users to actually make use of all this new capability.
The audience is probably listening and getting really excited and they want to do this in their own organization,
Yeah.
what could they do Tuesday at 10 o'clock in the morning to
Mm.
get started?
Great. The first thing I think one should do is sort of assess where you are right now in your journey. Try to understand what's your current state, and then what is it that you actually want to achieve. And then go out. There's a huge amount of information on Coursera, for example. Just browsing the other day, there's a course by the Mount Sinai School of Medicine, or wherever. There's a huge amount of information available to sort of get you to that next level and get you to the next step. But I think key is also understanding yourself. Where are you? Where do you want to go? And then putting the team together just to make sure that you arrive at the next step. And that may be very multivariate, but the really exciting thing for me is that there's a lot of pockets of excellence doing really exciting research from which you can draw. There's a huge amount of conferences which you can go to and talk to other people. This is how we met, right? We met in Berlin at the AI conference. And this is great. There's a huge amount of excitement around this whole field. So I think that's also one key thing that's propelling this whole process is people want to do this, and I think it's going to be easier to find the support even within your company to get the next step going, to get the ball rolling, so to speak.
Okay, thank you very much. So, what are some secrets to your success?
Thanks, Elizabeth. I love that question also because it implies that I'm actually successful. But be that as may. So I've sort of been very lucky in my career so far, in that sort of I consider myself sort of bilingual in that case. So I start off in the lab, and I was doing lab work for a long time, and I know the challenges that experimental work brings with it, and I appreciate the amount of work and effort that goes into generating good biological data in whichever context. And then I switched and started to learn and retrained as a computational biologist and computational scientist. Also, again, I was very lucky. I worked with excellent people, and who taught me a lot. But having been firsthand in both worlds I think is really valuable, because you appreciate the other side and you don't make assumptions that might be wrong, or less, hopefully. And in the past couple of 5 years, I've added like a third language to my repertoire, which is business, because I work with a company. And I understand, what value propositions is, and pain points, and to make sure that whatever you're developing, or wherever you're investing your time in, actually makes sense from a value proposition side, that you're actually challenging the problem or attacking the problem that gets you further in a business case, or even in a health space where you're actually maybe helping patients. So having lived in different scenarios, and always having lived and listened to excellent colleagues, I think this is also key, is to make sure that you're open to new information. Has been very exciting, and has brought me to where I am right now.
Thank you. And if our listeners want to reach out and get in contact with you, how could they do that?
Thanks. So yeah, I think the easiest way is just to go onto LinkedIn. You'll find my profile there. That's my name, Sven Zewitz. I'm also on Twitter, and my Twitter handle is @SvenAS71. So feel free to reach out any way you want, and I'm sure we can have a good conversation.
Okay, great. Thank you. And
Thanks
thanks
a lot.
everyone for listening. So have a nice rest of your day.
Thank you.